Good morning, students. In the last class, we are discussing about the series LCR circuit. That means an inductor having inductance L and capacitor having capacitance C and a resistor having the resistance R, which is connected to the AC source. So the applied voltage is V is equals to Vm sin omega t, and in the last class also we proved that the current which is flowing in the series LCR circuit, that is I is equals to Im sin of omega t plus pi, where pi is the phase difference between the current and voltage in series LCR circuit. So along with that, we also proved that Im is equals to Vm divided by Z, where Z is the impedance. So impedance is the opposing of the current which is flowing in the series LCR circuit, and we given that Z value, that is equals to under square root of R square plus Xc minus XL whole square, right? So where Xc is the capacitive reactance and XL is the inductive reactance, where R is the resistance. So its unit is also ohm, right? So in the last class we derived all these relations, right? So one more here, impedance triangle. So impedance we call Z as impedance. So impedance is nothing but the resistance, right? So impedance triangle. So we draw a right angle triangle, right? So the base represents the resistance R, and the side which represents Xc minus XL, and the angle is pi, and the hypotenuse represents what? The phase angle, that is impedance. So hypotenuse is what? The impedance Z, right? So the phase difference we can find tan pi, that is equals to opposite side by adjacent side, that is Xc minus XL divided by R, right? So this we can write phase pi is equals to tan inverse of Xc minus XL divided by R, right? So where pi is the phase difference between the voltage and to that of the current. So this triangle we call as impedance triangle, right? So next, electrical resonance, or simply we call this one as the resonance of AC, right? So what is electrical resonance, or simply resonance means when an AC voltage of particular frequency is applied to series LCR circuit. When an AC voltage of a particular frequency is applied to series LCR circuit, then current becomes maximum in the circuit. So this phenomenon is called resonance or electrical resonance, right? So what is electrical resistance? So applying the voltage, right? So that is V is equals to Vm sin omega t, right? So this voltage of a particular frequency, when we apply the voltage of a particular frequency, so where omega is the frequency, that is the angular frequency, right? So that frequency, when we apply to the series LCR circuit, so in this circuit, the current I which is flowing in the circuit, it becomes I maximum, right? So the current which is flowing in the circuit becomes the maximum. So that condition or that phenomenon we call as the resonance, right? So that is AC voltage of a particular frequency. So now ಯಾವುದಾದ್ರು ಒಂದು frequency ನಮಗೆ current which is flowing in the circuit ಏನಾಗುತ್ತೆ ನಮಗೆ maximum ಆಗುತ್ತೆ, right? So the current becomes maximum. So ಅಂತ phenomenon ನಾವು ಏನಂತ ಕರಿತೀವಿ, electrical resonance, right? So the definition is when an AC voltage of a particular frequency is applied to series LCR circuit, then current in the circuit becomes maximum. So this phenomenon we call as electrical resonance, right? So now we need to find the condition for electrical resonance. So condition means so namge yav condition alli idaga namge maximum irutte. So that's relation I. So namge ಏನು ಬೇಕು, I maximum ಬೇಕು. So I when is maximum, so applied voltage ಏನಿರುತ್ತೆ ನಮಗೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ. So ಇದನ್ನ ನಾವು ಯಾವುದೇ ತರ ಚೇಂಜ್ ಮಾಡಲ್ಲ for a applied voltage for a particular frequency, right? So that means this becomes constant. So only factor which we can vary that one is the impedance. So now impedance na change ಮಾಡ್ತಾ ಹೋಗೋದ್ರಿಂದ ನಮಗೆ I ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ as the impedance is inversely relates with the current. That means this value should be minimum is the ನಮಗೆ current ಏನಿರುತ್ತೆ maximum. Im is inversely relates with the impedance. So if impedance is more, that means resistance ಜಾಸ್ತಿ ಆದ್ರೆ current flow ಆಗೋದೇನಾಗುತ್ತೆ, ಕಡಿಮೆ ಆಗುತ್ತೆ. That is the property of the resistance or resistor, right? So ಯಾವುದಾದ್ರೂ ಒಂದು ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇದೆ ಅಂದ್ರೆ that means it opposes the flow of current. So ಇದು ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ current ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಫ್ಲೋ ಆಗುತ್ತೆ. So as impedance is also the resistance of the series LCR circuit. So ಈ ಮೂರನ್ನು ಕಂಬೈನ್ ಮಾಡಿದಾಗ ನಮಗೆ ಒಂದು ರೆಸಿಸ್ಟೆನ್ಸ್ ಬರುತ್ತೆ. So ಆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಗೆ ನಾವು ನೇಮ್ ಇಟ್ಟಿರೋದು impedance. So this impedance is nothing but the resistance or opposition of the flow of current. So ನಾವು ಈ opposition of the flow of current ನ ಕಡಿಮೆ ಮಾಡಬೇಕು ಅಂದ್ರೆ the condition is, so ಏನು ಕಮ್ಮಿ ಮಾಡಿದ್ರೆ ನಮಗೆ Z ಕಮ್ಮಿ ಆಗುತ್ತೆ. That is, so if we reduce R, we need to reduce all these three, right? So we make that is Z becomes R. That means only the resistance which is offered by the resistor, right? So again the resistance in the circuit is less. That means current which is flowing is maximum, right? So for that condition, for the maximum current, the condition is XC, that is equals to XL, right? So in this condition we are getting the maximum current, right? So when XC is for a particular frequency, right? So that frequency we taken as omega naught, right? So omega naught is the resonant frequency, right? So we know Xc is equals to 1 divided by omega c and XL is equals to omega L, where omega is the frequency. So here we are applying for a particular frequency. So Xc we can write 1 divided by omega naught c, that is equals to omega naught L, right? So omega naught square, that is equals to 1 divided by LC, and omega naught is equals to 1 divided by root LC. So this frequency we call as resonant frequency. So resonant frequency omega naught is equals to 1 by root of L, where L is the inductance of an inductor and C is the capacitance of the capacitor, right? So ಈ ಫ್ರೀಕ್ವೆನ್ಸಿಯಲ್ಲಿ ನಾವು ವೋಲ್ಟೇಜ್ ನ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಕರೆಂಟ್ ಏನಿರುತ್ತೆ ನಮಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇರುತ್ತೆ, ರೈಟ್? ಸೊ ದಟ್ ಬಿಕಮ್ಸ್ Im maximum, that is equals to Vm divided by under square root of R square plus, so that is we getting the maximum. So substituting here R square plus Xc minus XL, so this whole becomes 0. So only we getting the R square, right? First do the practice. Im is equals to Vm divided by under square root of R square plus Xc minus XL whole square. So So the condition is Xc is equals to XL. So substitute here Xc is equals to XL. So this term becomes 0. So that time Im max, that is equals to Vm divided by under square root of R square, that is equals to Vm divided by R. Right? So current, we getting the maximum current in the circuit. Im max is equals to Vm divided by R. So that means the maximum current is only relates with the resistance R. So as the resistance changes, we get the maximum current also changes, right? So if we plot the curve for Im versus frequency omega. So this is what Im max. So for a particular frequency, we are getting the current maximum. So that is the omega naught. So ಇಲ್ಲಿ ನಮಗೆ omega naught is the resonant frequency. ಈ frequency ಅಲ್ಲಿ ನಮಗೆ current ಏನಿದೆ peak ಅಲ್ಲಿದೆ. That means we getting the maximum current, right? So that is I max is equals to Vm divided by R. That means the current maximum current we are getting only because of the resistance. So resistance ಕಡಿಮೆ ಆಗ್ತಾ ಹೋದಂಗೆಲ್ಲ ಕೂಡ ನಮಗೆ maximum current ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, right? So if we taken few more, so we call this one as for R1, that is for the resistance R1. So in the green line we represent that is for R2. So in the black line that is R2. So three different resistors, if we connected to the series LCR circuit, so we getting the maximum current. So here we getting the maximum current for the resistance R2. That means R1, R2, R3 are the three different values. So where resistor na correct ಮಾಡಿದಾಗ ನಮಗೆ maximum current ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ change ಆಗ್ತಾ ಹೋಗುತ್ತೆ. That means the maximum current is directly relates with the resistance in the series LCR circuit. So here for example 10 ohm resistance connect ಮಾಡಿದ್ರೆ we getting here the maximum current. So if we reduce or if we increase the resistance for 15 ohm, we getting the resistance curve, the third is the second curve, and for the third if we increase this to some 20 ohms, so again we getting R3. That means R3 resistance is less than R2 less than R1. So ನಮಗೆ R3 resistance ಜಾಸ್ತಿ ಇದೆ, so that's why we getting the less maximum current. So R2 is little greater than that of the R3, hence we getting the I maximum curve here for the R2. So for the R1 we getting the maximum current. So ಈ ಎಲ್ಲವೂ ಕೂಡ ನಮಗೆ maximum current for their individual resistance. So resistance value ಮೇಲೆ maximum current ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ ನಮಗೆ change ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So resistance ಯಾವಾಗ ಜಾಸ್ತಿ ಇರುತ್ತೋ ಅಲ್ಲಿ ನಮಗೆ ಕರ್ವ್ ಏನಾಗುತ್ತೆ ಕಡಿಮೆ ಇರುತ್ತೆ. So this we call as the resonance curve. So the main important is for a particular frequency omega naught we are getting the maximum current. So this condition is only satisfied when in the series LCR circuit. So series LCR circuit ಅಲ್ಲಿ ಇದ್ದಾಗ ಮಾತ್ರ ನಮಗೆ resonant frequency ಬರುತ್ತೆ and we getting the maximum current, right? So in the circuit if we having only the inductor and the capacitor, then this will not be valid because here there is no resistance. Then Vm divided by 0 we getting Im is infinity, right? So understanding this one. So ಈ condition satisfy ಆಗಬೇಕು. I maximum is equals to Vm divided by R ಇರಲೇಬೇಕು ಅಂದ್ರೆ so that should be the series LCR. So ಈ ಮೂರು components ಕೂಡ ನಮಗೆ ಇರಲೇಬೇಕು. So if we consider only the inductor and resistor, so then also we won't get the maximum current in the circuit, right? So this is about the electrical resonance. So electrical resonance ಯಾವ್ದ್ರಲ್ಲಿ ಇರಬೇಕು ನಮಗೆ ಈ ಮೂರು components ಕೂಡ present ಇರಬೇಕು. So the condition for the resonance is Xc is equals to XL. That means the resistance value of the inductor is equals to the resistance value of the capacitor. Then the overall resistance of these two combination becomes zero. So we offered only the resistance by the resistor, right? So that time we getting the current. So that current we call as the maximum current, and this current is directly or this current is depends on the resistance R in the circuit. So R vary ಆದರೆ ನಮಗೆ I maximum ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ vary ಆಗ್ತಾ ಹೋಗುತ್ತೆ, right? So this is the resonance curve, right? So next, so this we can also write because omega naught is 2 pi f naught. So omega is 2 pi f. So omega naught we can write that is 2 pi f naught, that is equals to 1 divided by root LC, and f naught is equals to 1 divided by 2 pi root LC. So this is the another form, right? So idu angular frequency, idu only the frequency, right? So angular frequency is omega naught, normal frequency we denoted by f naught. So f naught on the particular frequency, right? By using resonance curve, right? So one more quality factor, or we call that one as Q factor, right? So in here we getting the resonant frequency omega naught. So along x-axis we take the frequency, and here along y-axis we taken that one as Im, that is the peak current. So here we getting the I maximum, right? So when we getting the I maximum, when the frequency which we are applied to the series LCR circuit, so that frequency must be equals to the omega naught, and the condition is omega naught is equals to 1 divided by root LC, right? So now frequency of the input voltage ನಾವು ಏನು frequency ಅಲ್ಲಿ ಕಳಿಸ್ತಾ ಇದೀವಿ ಆ frequency ನಮಗೆ omega naught value ಅಲ್ಲಿ ಇತ್ತು ಅಂದ್ರೆ ನಮಗೆ ಏನು ಬರುತ್ತೆ, we are getting the maximum current, right? So if the same frequency, so now ಕಳಿಸ್ತಾ ಇರೋ voltage ಅಲ್ಲಿ frequency which we are sending, so this frequency will be different value other than that of the omega naught. So now ಕಳಿಸ್ತಾ ಇರೋ value ಒಳಗೆ omega naught ಬಿಟ್ಟು ಬೇರೆ values ಕಳಿಸ್ತಾ ಹೋದ್ರೆ we getting the current which is always less than that of the I maximum, right? So if we send the input voltage with the different frequency, right? So that is not included with the omega naught. That is the resonant frequency, right? For example, here along x-axis we taken starts from 0 to omega, right? So for example, somewhere here I will sending the frequency of the value omega 1, right? So this frequency is other than that of the resonant frequency. So if frequency ಏನಿರಲ್ಲ ನಮಗೆ resonant frequency, for example, omega naught is equals to some 50 hertz, right? So ಈ 50 hertz ಅಲ್ಲಿ ನಮಗೆ ಏನು ಸಿಕ್ಕಿದೆ, maximum current ಸಿಕ್ಕಿದೆ. That means here we having the frequency of 50 hertz. So now I am sending the voltage other than this resonant frequency. ಈ 50 hertz ಬಿಟ್ಟು ಬೇರೆ hertz ಅಲ್ಲಿ ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, input voltage na ಕಳಿಸ್ತಾ ಇದ್ದೀನಿ. That means either it may be value may be increase or value may be decrease. So ನಾನು 50 ಗಿಂತ ಜಾಸ್ತಿ ಅಂದ್ರೆ some 80 hertz ಅಲ್ಲಾದ್ರೂ ಕಳಿಸಬಹುದು ಅಥವಾ 100 hertz ಅಲ್ಲಾದ್ರೂ ಕಳಿಸಬಹುದು, right? So these are the values which are greater than the resonant frequency, and in some frequencies some 30 hertz or some 40 hertz, right? So ಈ frequency ಅಲ್ಲಿ ಕೂಡ ನಾನು input voltage na ಕಳಿಸಬಹುದು, right? That means the values which are less than that of the resonant frequency and the values which are greater than that of the resonant frequency. So ಈ frequency ಅಲ್ಲಿ ನಾನು current na send ಮಾಡಿದ್ರೆ, so the current which is always less than that of the maximum current, right? So ಈ frequency ಬಿಟ್ಟು ನಾನು ಬೇರೆ ಯಾವುದೇ frequency ಅಲ್ಲಿ ನಾನು current na, that is voltage na send ಮಾಡಿದ್ರೆ series LCR circuit ಗೆ, so that current in the circuit is always less than that of the maximum current. So for example, omega 1 here I am sending some 40 hertz. So now omega 1 ಅಂದ್ರೆ some 40 hertz ಅಲ್ಲಿ current na set ಮಾಡ್ತೀವಿ. At this frequency we need to find the current. That means projected the omega 1 value so vertically upwards and so along here. So I am getting I1 here, that is Im. So compare these two values. I maximum is here, so for example some 10 amperes, right? So this I am getting some 2 amperes, right? So 40 hertz ಅಲ್ಲಿ ಕಳಿಸಿದ್ರೆ ನನಗೆ 2 ಆಂಪಿಯರ್ ಬರ್ತದೆ, ಬಟ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕರೆಂಟ್ ಎಷ್ಟಿದೆ ನಮಗೆ 10 amperes ಇದೆ. So same way if I increase the frequency which is greater than that of the resonant frequency, some 80 hertz, so somewhere here I am sending the frequency that is of omega 2. So ಇಲ್ಲಿ ನಾವು current find out ಮಾಡಿದ್ರೆ again we getting here, that is Im. So observe this, I maximum is greater than Im. So similarly up to here, so ನಾನು omega naught ಬರೋವರೆಗೂ ನಾನು ಏನು frequency send ಮಾಡ್ತೀನೋ, so that current is always less than that of the I maximum, right? So ಅದನ್ನ explain ಮಾಡಿದ್ದೀನಿ. This is omega naught and again here Imax, right? So that means for a frequency, resonant frequency, we are getting the Imax. So other than frequency, that is other than resonant frequency, if we apply to the input voltage, so that current will not exceed the I maximum. So illinda ಜಾಸ್ತಿ ನಮಗೆ current ಬರಲ್ಲ, always it is less than that of the I maximum current, right? So now consider such a case that, so here omega naught is equals to 1 divided by root LC, right? So now consider such a case that I am sending the frequency in such a way that this current is reduced to 1 by root 2 times of its maximum current. So ನಾನು ಯಾವುದೋ ಒಂದು frequency ನ send ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಆ frequency ಎಷ್ಟು ಇರಬೇಕು ಅಂದ್ರೆ, so we are getting the current, so that current I is equals to Im max by root 2, right? So I am sending the frequency omega, so such that it is not the resonant frequency. So other than the resonant frequency, I am sending the value. So this value for this frequency, the current which is flowing in the circuit should be equal to I maximum by root 2, right? So considering this situation, so ನಾನು ಯಾವುದೋ ಒಂದು AC voltage ಗೆ frequency send ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಆ frequency ಯಾವ ತರ ಇರಬೇಕು ಅಂದ್ರೆ current in the circuit will be equal to 1 by root 2 times of its maximum current. That means, so somewhere here I am getting 1 by root 2 times of its maximum current, right? So that we taken as omega 1, right? So we taken omega 1, that is equals to omega naught plus delta omega. So delta omega is a smaller frequency exceeding the omega naught. That means omega 1 is greater than omega naught. So omega naught means on ಸ್ವಲ್ಪ ಜಾಸ್ತಿ frequency ತಗೊಂಡಿದೀವಿ, so that we denoted by omega 1. So somewhere here, so we taken omega 1. So omega 1 is equals to omega naught plus delta omega. That means this distance or this change in frequency is delta omega, right? So we written omega 1 in terms of omega naught means omega 1 is equals to omega naught plus delta omega. We getting the value omega 1. So this is greater than the omega naught. So two frequencies we are taken, one is greater than resonant frequency and another one is lesser than resonant frequency. So that is omega 2 is equals to omega naught minus delta omega. So the reference is the resonant frequency. So illige, so that we taken as omega 2. So that's the difference is also how much, that is delta omega, right? So ಈ ಎರಡು frequency ಯಾವ ತರ ಇರಬೇಕು ಅಂದ್ರೆ applied frequency that must be equals to 1 by root 2 times of the I maximum, right? Right, so we get it omega 1, we get the current I by root 2 of I maximum. Omega 2, we get the I by root 2 of Im maximum, right? So now difference these two, that is subtract these two equations, that is omega 1 minus omega 2, that is equals to subtracting these two, omega naught get cancelled, plus delta omega minus of minus, that is plus delta omega, we get 2 delta omega, right? So we call this one 2 delta omega as bandwidth. We call that one as the bandwidth, right? So omega 1 minus omega 2, that is equals to 2 delta omega, that is we getting by subtracting these two relations. So ಎರಡು ರಿಲೇಷನ್ ನ ಫ್ರೀಕ್ವೆನ್ಸಿ ನ ಡಿಫರೆನ್ಸ್ ಮಾಡಿದ್ರೆ ನಮಗೆ ಒಂದು ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ delta 1 minus delta 2, that is omega 1 minus omega 2 is equals to 2 delta omega. That means omega 1 minus omega 2 is equals to the length, width between the two frequencies, we call that one as the bandwidth, right? So delta omega plus delta omega, we getting 2 delta omega, right? So here we need to find the quality factor, that is the sharpness of the curve, right? So that we defined by, it is the ratio of resonant frequency to that of the bandwidth, right? So quality factor is defined as, it is the ratio of the resonant frequency, where omega naught is the resonant frequency, that is divided by 2 delta w, that means the bandwidth. So we taken this value as the bandwidth, the width between the two frequencies. So this gives what the measure of sharpness of curve. So e value ನಮಗೆ ಏನು ಕೊಡುತ್ತೆ, sharpness of the curve ನ represent ಮಾಡುತ್ತೆ. So that's why we taken this value as the quality factor or Q factor, right? So Q factor is defined by, it is the ratio of the resonant frequency to that of the bandwidth, right? Resonant frequency to that of the bandwidth, right? So we need to find the relation for the Q factor in a series LCR circuit, right? So considering the relation for this one, that is omega 1, right? For the current Im, that is equals to Vm divided by Z, where Z is the impedance, right? So this we can write Vm divided by under square root of R square plus Xc minus XL whole square. So we can also write that one as Vm divided by under square root of R square plus omega C minus 1 by omega C minus omega L whole square. Right? So here we are not sending the frequency, that is the omega naught. So I am taking the frequency that is omega 1. So hence wherever omega we can take, that is omega 1. Right? So in this frequency, this current is equals to 1 by root 2 times of the I maximum. Right? So that's why I take that one as Im maximum by root 2, that is equals to Vm by under square root of R square plus, so we can write this one as omega 1 C minus, that is omega 1 L minus 1 by omega 1 C, right? So ಇದನ್ನು ಯಾವ ತರ ಆದರೂ ಬರ್ಕೋಬಹುದು because it is in square. So if we take minus common outside, so square again we getting the plus, right? So this relation we having this Im maximum. So Im maximum when we are getting, so that is we are getting when the resonant frequency omega naught, that is Im maximum is equals to Vm divided by R. So this we stated in the last one, right? So Im maximum is equals to Vm divided by R. So we can replace this with Vm divided by root 2 into R, that is equals to Vm divided by under square root of R square plus omega 1 L minus 1 by omega 1 C whole square, right? So Vm get cancels. So squaring on both sides, so we can write this one as R square plus omega 1 L minus 1 by omega 1 C whole square, that is equals to 2 R square, right? So this R square if we shift to the RHS, so again we getting here we are discussing omega 1, so I will write omega 1 is equals to omega naught plus delta omega. So this omega 1 value. So that we can write omega 1 L minus 1 by omega 1 C whole square, that is equals to R square, right? 2R square minus R square, so we getting the R square value, right? So taking square roots on both sides, so we can write omega 1 L minus omega 1 C, that is equals to R, right? So omega 1, here we have the value omega naught plus delta omega, right? So substituting here omega naught plus delta omega into L minus 1 divided by omega naught plus delta omega into C, that is equals to R, right? So we need the relation omega naught by delta omega, right? So taken omega naught as common, 1 plus delta omega by omega naught into L minus 1 divided by the denominator also omega naught 1 plus delta omega by omega naught into C, that is equals to R, right? So now So this we can write omega naught L into 1 plus delta omega by omega naught minus. So omega naught we can write 1 by root LC, or so this we can write omega naught square is equals to 1 by LC. So in place of C we can write, from this we can write C is equals to 1 by L omega naught square, right? So writing that one divided by omega naught 1 plus delta omega by omega naught. So in place of C we can write 1 divided by L omega naught square, that is equals to R. So omega naught get cancelled. So this we can shift to the numerator. So 1 divided by this value we can write omega naught L 1 plus delta omega by omega naught minus omega naught L. So this also we can shift to the numerator. So that becomes 1 plus delta omega by omega naught go to the power of minus 1, that is equals to R. So this we are going to expand, that is a plus b x plus a whole to the power of minus 1. So if we expand this one, we get 1 minus delta omega by omega naught plus delta omega by omega naught whole square. So as delta omega is very small, so square terms also we getting the very lesser value. So we can neglect the higher order terms. So we can write omega naught L 1 plus delta omega by omega naught minus omega naught L, we can write this one as delta omega by omega naught, that is equals to R. So ಇದು ನಾವು by mathematical induction ಅಥವಾ x plus k, so ಅದನ್ನ whole power minus 1 ನಾವು expand ಮಾಡೋದು higher values ಬರ್ತಾ ಹೋಗುತ್ತೆ. So neglecting the higher values, square, cubes terms na neglect ಮಾಡಿದ್ರೆ we can only write this one 1 minus delta omega by omega naught. So in these two terms omega naught L is common, we can take common 1 divided by delta omega by omega naught minus 1 plus delta omega by omega naught, that is equals to R. So plus 1 minus 1 get cancelled, so denominator same and numerator also same. We can write this one as 2 delta omega by omega naught, that is equals to R. So we need omega naught by 2 delta. So this we can replace omega naught by 2 delta omega naught. So ಇದನ್ನು RHS ಗೆ shift ಮಾಡಿದ್ರೆ, so we getting omega naught L divided by R. So this we call that one as Q factor. So Q factor is equals to omega naught L divided by R. So idu by substituting the inductance and resistance value, so we getting the Q factor, that is the sharpness of the curve. So idu ನಾವು ಪ್ರಾಬ್ಲಮ್ಸ್ ಮಾಡಬೇಕಾದ್ರೆ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ day of formula, that is Q factor is equals to omega naught L divided by R. So where omega naught is the resonant frequency, where L is the inductance and R is the resistance. So this is in case of inductance. So same if you write that one in case of resistance, sorry, in capacitance, right? So Q, that is equals to omega naught L divided by R. So again by this relation, so we can write L, that is equals to 1 by omega naught square C. So E relation in the name L is equals to 1 by omega naught square C. So substituting here, Q is equals to omega naught into 1 divided by R into omega naught square C. So omega naught square get cancelled. So Q factor, that is equals to 1 divided by omega naught R C. Right? So this is in terms of inductor and this is in terms of capacitance, right? So we know the relation omega naught, that is equals to 1 divided by root L. So we can substitute here or here. So ಎರಡರಲ್ಲಿ ನಾವು ಇರಬೇಕಾದ್ರೆ substitute ಮಾಡಿದ್ರೆ we get Q is equals to 1 divided by, so in place of omega naught we need to substitute, that is 1 by root LC into RC, right? So this goes to the numerator, that is root LC divided by RC. So in the denominator C, we can write that one as root C into root C. So we can get Q factor, Q is equals to 1 divided by R under square root of L divided by C. So this is the final expression for the Q factor that relates with the resistance, inductance and capacitance. So same we can substitute here also, right? So omega naught is 1 by root LC into L divided by R. So L we can write that one as root L into root L. So we get Q, that is equals to 1 divided by R. So that is equals to L divided by C. So now we all substitute model, we get the final relation for the quality factor to measure the sharpness of the curve. That is Q is equals to 1 by R under root of L by C. Right? So namage omega naught kottu resistance matte capacitance kotre, we can go through this relation, that is the resonant frequency. So if they given the inductance means we can go through this relation. So or if they won't give any omega naught, that is the resonant frequency koddale namage R L C values kottidru andre, we need to use the relation Q is equals to 1 by R under root of L by C. So idu namage derivation genu illa. So we need to remember the definition. Quality factor, that is the ratio of the resonant frequency to that of the bandwidth, omega naught by 2 delta omega, right? So this is the derivation to get the relation Q, that is equals to 1 by R under root of L by C, right? So in the next class we will discuss with the power in an AC circuit, that is in series LCR circuit. Thank you.